So when I say carbon dioxide, what's the first thing that pops into your head? Probably climate change, right? The villain of the story. But what if I told you that the very gas we're all trying to cut back on could actually be a key part of the solution for a cooler, more sustainable future? Well, stick with me because we're going to dive into how this forgotten tech is making an absolutely incredible comeback.
I know, it sounds kind of crazy, doesn't it? It's a total paradox. But that very same molecule, CO2, it's got this hidden identity. It's not just a greenhouse gas. Turns out it's also a highly effective, totally non-toxic, and really environmentally friendly refrigerant that's re-emerging as a top contender in the world of cooling. Okay, so to really get why we even need a new cooling champion, we've got to look back at the mess our old ones made. For pretty much the last 100 years, our mission to stay cool has, well, it's led us down a chemically complex and pretty damaging path.
And the way we measure this mess, the key number you need to know is something called global warming potential, or GWP. The idea is actually pretty simple. It just compares the warming effect of any gas directly to good old carbon dioxide, which we give a baseline score of just 1.
This is just a classic story of our solutions creating brand new problems. First, we had CFCs. They were fantastic at cooling, but whoops, they were literally shredding the ozone layer. So the world got together and phased them out. But the replacements, first HCFCs and then HFCs, well, they fixed the ozone problem, but it turned out they were incredibly potent, super potent greenhouse gases.
And when you see the numbers side by side, wow, the difference in impact is just staggering. A standard HFC refrigerant, like R134A, which is probably in your car's AC right now, has a GWP of 1300. That means it traps 1300 times more heat than CO2. This is the exact dilemma that forced us to start looking for a much, much better way.
All right, so that's the problem. And this brings us right back to our unlikely hero. The search for a truly safe refrigerant has led innovators to look not to the future, but way back to the very, very beginning of refrigeration tech itself.
You see, using carbon dioxide for cooling, it's not a new idea. Not at all. It was one of the originals, first used way back in 1866. By the 1930s, it was the king of marine refrigeration. But then these new synthetic refrigerants like Freon showed up, and CO2 was just abandoned. It became forgotten technology until the environmental crises of the 90s brought it roaring back.
And this whole revival, it was really championed by scientists like Gustav Lorentzen back in the early 1990s. Just as the world was phasing out those ozone-killing chemicals, he had this incredible foresight. He saw that this old, natural substance wasn't just another option. It was potentially the best refrigerant for solving this new problem of global warming from HFCs.
So you have to ask, right? If it was so great, why did we ever stop using it? Well, it really just comes down to physics. CO2 has a really low critical temperature, only about 31 degrees Celsius. And with the tech they had back in the 1930s, that made CO2 systems kind of inefficient, especially in warmer places. They just couldn't hang with the new CFCs.
But here's where it gets really cool. The genius of the CO2 revival wasn't just about bringing back some old refrigerant. No, it was about inventing a completely new way to use it, turning what everyone thought was its biggest flaw into its greatest strength.
This, right here, was the light bulb moment. Instead of fighting with CO2, trying to force it to act like a traditional refrigerant and condense into a liquid, which is really tough above 31 degrees, Lorentzen designed a system that operates in what's called a transcritical state. He didn't fight its unique properties, he embraced them. So let me break down how this super elegant cycle actually works. First up, the CO2 gas gets compressed into this dense, hot, supercritical fluid. It's this weird state that's kind of like a gas and a liquid at the same time. Next, that fluid flows through a gas cooler, releasing a huge amount of heat. Then it expands, which causes this massive drop in temperatures. And finally, that super cold CO2 evaporates, soaking up heat and making things cold, before the whole cycle just starts all over again.
So that basic cycle, it was totally revolutionary. But of course, modern engineers didn't stop there. No way. They've developed this whole series of clever upgrades that have pushed the efficiency of CO2 systems to a completely new level, making them just as good, and often even better, than the synthetic stuff.
Okay, upgrade number 1, the internal heat exchanger. Basically, this thing uses the cold gas that's coming out of the evaporator to pre-cool the hot fluid right before it expands. It's like recycling a bit of coldness that you'd otherwise just throw away. So smart.
And what do you get from that one simple trick?
an immediate 5 to 10% boost in the system's efficiency. Now, that might not sound like a ton, but over the life of an appliance, that's a serious energy saving that you'll definitely notice on your power bill.
All right, next up, another big improvement is to split that single big compression step into two smaller, more manageable stages with a little cooling in between. Doing this dramatically reduces how much energy the compressor actually needs to do its job.
And how much difference does that make? Oh, it's a big one. This upgrade alone can make the system over 21% more efficient. That is a huge leap in performance, squeezing way more cooling power out of the same amount of electricity.
But maybe the biggest, most powerful upgrade of them all is replacing a simple valve with a tiny turbine-like thing called an expander. Instead of just letting all that high-pressure energy go to waste when it expands, an expander actually captures it and uses it to help power the compressor. It's brilliant.
And here's the thing. It turns out CO2 is just built different. It's uniquely suited for this. Because of its physics, a CO2 expander can recover about 37% of the energy used by the compressor. For standard refrigerant, that number is only around 15%. I mean, CO2 is just way better at giving that energy back.
So the impact here, it is just massive. By recovering all that otherwise wasted energy, an expander can boost the whole system's efficiency by up to 33%. You start combining these upgrades, and CO2 goes from being this quirky alternative to a true world-class performer.
Okay, so this isn't just some science project. This tech is out in the real world, right now, changing how we keep things cool. So where can you actually find it?
Well, you'll find these advanced CO2 systems in some of the latest car air conditioners, in super-efficient heat pump water heaters, in commercial vending machines, and more, in the entire refrigeration systems for big supermarkets, where they are replacing HFCs on a massive scale. And if you want to see just how successful this can be, you got to look at Japan. Their EcoCute program for CO2 heat pump water heaters launched back in 2001. By 2007, they'd already sold over 1 million of them. And just 2 years after that, they blew past the 2 million mark. I mean, this is a proven, totally commercialized, and wildly successful technology.
You know, the whole story of CO2 refrigeration is just amazing. It shows us that sometimes the solution to a huge modern problem isn't some brand new invention. Sometimes it's just a clever new perspective on something old we thought we already understood. It really makes you wonder, what other so-called environmental problems are actually solutions in disguise, just waiting for us to look at them in a completely new way?